Good evening, guys. I welcome you all on this wonderful platform that is BYJU'S Exam Prep. Please tell me, am I properly audible and visible to all of you or not? Sushanta, good afternoon, dear. So, guys, as per the promise, I told you now the timing of the session would be 5 p.m. So, we are meeting at 5 p.m. Just like and share the session so that other students can also reach to this session. So, guys, today's topic of ours is degree of freedom. But as you know, when yesterday we were having a discussion on the simple mechanism, we have done the discussion on the types of links, we have discussed about the types of motions, and we started the discussion on the types of pairs. I also told you every kinematic pair is a pair, but every pair need not to be a kinematic pair. So let's start the discussion now, guys. So my dear, before we start, this is some introduction about me. And my dear, the subject for today is theory of machines. Okay, so my dear, now I would like to tell you about the concept capsules which are going to be started in this week only. So my dear, in this we would be having a discussion about some very important concepts. Okay, and those concepts would be helpful to you in the GATE examination, also in all the interviews, ISRO, BARC, these kind of examination as well as the interview preparation. So guys, these are going to be the concept capsules to help you. For mechanical civil, Tuesday and Saturday would be the time. Tuesday and Saturday they would be coming. So from in upcoming Tuesday you would be having the very first concept capsule from our side. Okay, so be ready for that. And the timing for this concept capsule would be 9 a.m. So in the morning you would be having this capsule, okay, so that your day would be going good, very good technically. So let's start, guys. So my dear, now this is a very important announcement related to a session, and that session is related to how to ace GATE 2023 in the very first attempt, and the session is on 8th May 12:30 p.m. So my dear, just register now. It is a free session, would be taken by Ashutosh Saxena sir. So guys, let's move to our session now. So we were talking about the types of kinematic pairs, and we have discussed the very first pair. Manas, good evening. Midun, yes, good afternoon, dear. So guys, the very first pair we have discussed was the turning pair, and I told you if relative motion between two links is pure rotation or circular motion, then it is said to be the revolute pair, rotary joint, or turning pair. So this is the example of that. You can see shaft, this is shaft, this is shaft, and this is shaft inside the bearing. So you know that the relative motion between shaft inside the bearing, shaft is going to be rotated and bearing is going to be fixed. So relative motion is pure rotation. So it is an example of turning pair. So my dear, this is we have discussed yesterday only. Okay, and within 10-15 minutes this pairs part would be over. Then we would be entering into the degree of freedom concept. Then my dear, we have also seen the sliding pair. When the relative motion between two links is sliding, like you can see this square shaft in the square hole can reciprocate only. So this is the example of prismatic or sliding pair where the relative motion between two links is sliding motion. Then my dear, there is an example of screw pair. Screw pair means nut bolt type of connection. When you have a bolt and a nut, my dear, that connection is coming under the category of screw pair. So my dear, when we are talking about screw pair, you can feel, in screw pair what is going to happen. If you would be having a bolt like this, okay, and on this bolt you are going to use a nut. When you would be giving rotation to the nut, then my dear, in every complete rotation this nut is going to move in the translation also. But when it would be moving in translation, it is for sure that in one cycle it would be going one pitch distance forward. So it means it is fixed that one revolution will result into one pitch distance inside. Ayush, Vishwas, good evening, dear. So my dear, if that is the thing, it means this rotation and translation are having some connection to each other. Some students say, sir, you told us that a constrained motion is a desired motion, which is a unique type of motion. So here there are two motion, whether this is an example of kinematic pair or not, because any pair will become a kinematic pair if the relative motion between the link is becoming constrained. Constrained means unique desired motion. But here there are two motion, because this nut is going to rotate as well as translate. But my dear, this translation and rotation not independent. They are depending on each other, because one revolution of this nut will give you one pitch translation. It means they are connected to each other. It means this 2 pi r of circular motion will give you an equivalent translation of pitch distance if it is a single start thread. So my dear, if that is relation between these two motion, we will call it as independently it is one motion only, it is not two motion. So when two motions are depending on each other, we call them a unique motion only. We will not say them as two motions. Okay, so guys, just like and share the session. Then my dear, there is a pair which is called as spherical pair. So my dear, when we have three-dimensional rotation, between two bodies, we would be calling it as a spherical pair. Such a pair is available in our body, guys. If you see the movement of our head like this is rotation about one axis, this is rotation about another axis, rotation about one axis, rotation about another axis, rotation about third axis. So my dear, this can have three-dimensional rotation motion. So if anybody can have three-dimensional rotation, such pair is said to be spherical pair. Other examples of spherical pair are your bike mirror, your car mirror. My dear, that bike mirror also you can rotate in three dimension. Car mirror also have the similar motion. If you remember, at some time, I will say some years before, having a BlackBerry phone seems to be some standard. So those BlackBerry mobile, they were having some ball in between, and that ball was also having three-dimensional rotation. That was also an example of spherical pair. Joystick, spherical pair. Ball and socket joint, spherical pair. So my dear, ball and socket from our body, I am telling you. So guys, whatever these joints are, all these are said to be the spherical pair. So if relative motion is three-dimensional rotation, it is said to be a spherical pair. So I feel everybody understood about, and this whatever I have shown, this is ball and socket joint. Okay, so this is present in our body. हमारे घुटनों में होता है ball and socket joint. I feel everybody understood this. So my dear, yes, Nagaraju, good afternoon. Dear Ranjit, spherical pair considered lower or higher pair? Dear lower pair. Ranjit, I have not discussed till in this session lower higher pair, but it would be covering under lower pair. Why? Because my dear, this hand, this part of your hand with this arm is not connected at a point. This is connected at a surface only. So between this and this, there is no point contact. This is surface contact only. So it is said to be lower pair, but still I am coming on to lower higher pair. Don't worry about that. So my dear, this is something about this type of pairs, and we have discussed all the types of pairs. We are left with only one type of pair, that is said to be the rolling pair. And after this, we would be entering into the joints and chain, and then we would be having the concept of degree of freedom. So my dear, we are talking about rolling pair. So when we are talking about the rolling pair, my dear, if relative motion between two links is pure rolling, so I will say if relative motion is pure rolling, if relative motion is pure rolling, so if relative motion between the links, if relative motion between the links is pure rolling, then my dear, we call it as, rolling pair. Yes guys, I feel everybody is getting it. And guys, just like and share the session. I want more and more people to join, because I am teaching everything from scratch so that you can get everything in detail. Okay, so my dear, when we are talking about pure rolling motion, actually in thermodynamics you have studied some kind of processes. What are those processes, guys? You have studied isothermal, you have studied isobaric, you have studied isochoric, you have studied adiabatic, you have studied polytropic. So all these kind of processes you have studied in the thermodynamics. So actually, if you talk about isobaric, pressure constant, isochoric, volume constant, isothermal, temperature constant, adiabatic, heat zero. So my dear, other than these four processes, whatever the rest infinite processes are pending, those are given the name of polytropic process. So polytropic process is not a single process. Other than for whatever the possible process, they are polytropic processes. Because for polytropic, you say PV to the power n is equals to constant, where n is anything from minus infinity to plus infinity. So my dear, it means for different values of n, we would be having different processes. It simply means that there are many processes other than those four, all are given the name of polytropic processes. Likewise, my dear, when we are talking about the motions, there are only two fundamental motions. Like the very first fundamental motion is pure translation. Very first fundamental motion is pure translation. And my dear, this pure translation motion is having a quality. I would like to say there is a point which this pure translation motion is always following. Let us say we are having a block on the fixed surface. We are having a block on the fixed surface, and if you are saying this block is moving with a velocity of 5 meters per second. So if this block is moving with 5 meters per second, my dear, and if it is in pure translation, then my dear, it would be following one condition. That one condition is velocity of every point present on this slider would be same. Means this point would be having a velocity of 5. This point would be having a velocity of 5. This point would be having a velocity of 5. This point would be having a velocity of 5. So every point has same translational velocity. This is the property of pure translation motion. This is the first fundamental type of motion which we are very well aware of. And my dear, you can have this pure translation in any case. Like many times, whenever, my dear, let us say sometimes your car wheels are going to skid in the bad weather conditions. Okay, so sometimes they are getting skid like this, and when they are skidding, actually what is going on? If you are considering this a car wheel, in reality car wheels are running like this. Okay, they are running like this. But my dear, in bad weather condition, sometimes it happens that there is a lot of you can say when we have some bad weather condition like rains are coming. So because of bad road condition, your car sometimes is just going like that without rotating, the wheels are moving like this. This condition is said to be pure translation or skidding for the car. So my dear, when we are talking about this condition, in this condition the wheels are also going under pure translation. So because of that, for this condition, every point on the wheel is having same translational velocity, and this condition is said to be pure translation or skidding of the wheel, what you have seen and definitely felt many times. So my dear, now this is the first fundamental type of motion. If you ask me the second fundamental type of motion, that is pure rotation. So these are the topics which you understand in engineering mechanics, but I am teaching you in term because they are going to be used in throughout the theory of machines. When we are like machine design is application of some, theory of machines is application of engineering mechanics. So my dear, we are talking about the pure rotation motion. So my dear, like here, if translation velocity is constant, that is the property. So for pure rotation, the property is every point would be rotating with the same angular velocity. So my dear, when every point would be rotating with the same angular velocity, let us say this is the center point. So if you take any point on this body, that would be having same angular velocity. Angular velocity means same omega. So my dear, if you are asked about this point omega, this point omega, this point omega, this point omega, every point would be having the same angular velocity, that is omega. But we know linear velocity V is R into omega. So my dear, if you want to find out R is the distance from the center. So my dear, if R would be changing, velocity would be changing. And because of that, my dear, if you are going to start from the center, velocity would be maximum at outer because R is going to be maximum here. And other than that, it is going to be very linearly. At center, R is 0, so velocity is also 0, and it would be reducing linearly like this. And as when this body is rotating with the omega, so here it is moving like this and going like this. So here the velocity would be coming in opposite way. So my dear, this is going to be the velocity profile for a pure rotating body. Pure rotation means when body is going to rotate at one position, it is not moving. So sometime when you are going to get into some desert, some Registan kind of thing, then my dear, your wheels would be rotating but your car would not be moving. That is the condition when your wheels are going to have pure rotation motion. Means they are rotating, placing at one point, means their center of rotation or axis of rotation is fixed at that time. That motion is said to be pure rotation. So let us say this velocity is 5, this is 4, 2, 1, 0, minus 1, minus 2, minus 4, minus 5. This is the velocity profile. So these two are the fundamental types of motion, my dear, in engineering mechanics and theory of machines. Other than these two types of motion, whatever the motion you know about, those all kind of motion comes under the category of general motion. So my dear, only two motions are fundamental, all other infinite motions are general motion. Out of those infinite motions, my dear, there is some motion known as simple harmonic motion. Similarly, there is some motion known as pure rolling motion. So we are talking about the pure rolling motion, which is a special case. And other than these two fundamental motion, all other motions can be derived by any of these two types of motion. Means either it would be derived from rotation like SHM, or it would be derived from translation plus rotation like I am showing you the pure rolling motion. So all other motions can be derived from the combination of these two or any of these two. So let us see, my dear, the pure rolling motion. So my dear, when you are defining pure rolling, what is the condition for pure rolling? What is the condition for pure rolling? So my dear, when we are talking about pure rolling motion, so you are having a body like this, and you are saying this body is given an angular velocity of omega, which was the same as that of pure rotation. But at that time, body was rotating about a fixed axis. But here, my dear, when I am saying body is rotating, this time body is also moving along a path, because we are putting a condition on this motion, and that condition is that if at this point there is a contact between this body and the surface, so the velocity of this point A should be 0. So if you satisfy that we are going to rotate it with omega, at the same time velocity of point of contact is 0. If you satisfy these two conditions, such a motion is given the name of pure rolling motion. So this is the condition for pure rolling motion. Now my dear, we will try to understand this motion, and after understanding this, my dear, we would be entering into the kinematic chain, and once we will enter into kinematic chain, our degree of freedom would be started. So today I would be telling you the concept of degree of freedom, okay? Then slowly we will be entering into Gradeup flow and all other topics. Let us move further, guys. Let us move further. Today we have some numerical also on the pure rolling. Okay, so guys, let us move. So when we are talking about the pure rolling, we have just discussed that we have given this body an angular velocity of omega, and we have just seen when it would be given an angular velocity of omega, we would be having this kind of velocity profile. So if you see this kind of velocity profile, according to this, if here velocity is +5, here velocity is -5. So this is the case of pure rotation. But we very well know that if we want to make it a pure rolling motion, my dear, if you want to make it a pure rolling motion, then the velocity of point of contact A should be 0. But here velocity of A is coming out to be -5. So anyhow, we need to convert this -5 into 0 velocity. So my dear, can you tell me how this -5 can become 0? You will say simply, sir, add 5 into that. But dear, we have to add 5 into that, but there should be some logic behind that. Not just to make it 0, we will write it +5. So my dear, for that, as you know, we are only aware of two motions. One is pure translation, other is pure rotation. So my dear, the simple thing is, if we give a pure translation motion, if we give a pure translation motion of 5 meters per second to the same body, so if we give the 5 meters per second pure translation to the same body, then my dear, this -5, this +5 would become 0. So if you make the equivalent velocity profile, it would be coming like this. You can see -5 + 5 would become 0. So -5 + 5 would become 0. So velocity is 0 for this point. 5 + 5 would become 10. So velocity is becoming 10 for this point. For center, it is going to be 0 + 5. 0 + 5. So my dear, it is going to be 5. And you would be having this linear profile. And this is going to be the velocity distribution. This is how we can make it. So 10, 0, 5, 8, 6, 4, 2, like this. So this is the linear velocity profile. So my dear, you can see this was nothing but pure rotation. And to satisfy the condition of pure rolling, we have given an addition of pure translation into that. So my dear, if you see, pure rolling is a combination of, pure translation and pure rotation. Pure rolling is a combination of pure translation and pure rotation. So my dear, if pure rolling is a combination of pure translation and pure rotation, you once again say, sir, you were talking about unique motion. Once again, two motions are coming. But my dear, these two motions are very much interconnected, because this 5, which is nothing but R maximum into omega, that is equals to this translational velocity. Because if you would try to give this velocity other than the 5 value, it will not be becoming the pure rolling motion. Because if you add 6 meter per second, then -5 plus 6 would become +1. This would not be a pure rolling motion. So pure rolling motion is possible only for this condition, which is giving relation between this translation and rotation. So yes, pure rolling is a combination of translation and rotation, but independently it is said to be one motion only, because both the motions are related to each other. So I feel everybody is getting it properly. Is it fine or not? Please tell me that, guys. Is it clear to you or not? And yes, guys, please tell me. And guys, don't worry, I would be having numericals also on all the topics, so don't worry about that. Theory plus numerical, every respect, this chapter when I am teaching you, you would be able to make all the questions. That is guaranteed. Very good. Wonderful. So guys, with this we have completed all the types of pair related to the relative motion, according to the type of relative motion. Then my dear, we are talking about the according to the type of contact. According to the type of contact. Okay guys. So my dear, here I would like to say something, that if two links are connected in such a way that they are joined with surface contact, then such pairs are said to be lower pair. And if the contact between two links is point or line contact, it is said to be higher pair. If you want to see the example of lower and higher pair, I would be showing you these figures. If you see here, shaft is inside the bearing. So my dear, can you tell me the contact between shaft and bearing? Is it surface contact or point contact or line contact? If shaft is inside the bearing like this, is it surface contact or is it point or line contact? What do you say, guys? I feel it is very simple to understand what type of contact it is. It is surface contact. Now, my dear, when somebody is sliding, let us say this is sliding like this. So here what type of contact is there? Obviously surface contact is there. When, my dear, you are having a screw pair where a nut is going on over the bolt, my dear, once again you would be having the lower pair. So in this case, in this case, in this case, everywhere surface contact is there. In spherical pair also you can see the ball, half ball is inside the socket. So my dear, here also surface contact. And my dear, in this planar pair also this body is completely in contact with the lower surface. So my dear, whatever the examples I have shown here, all these types of pairs comes under the category of lower pairs. So I would be saying that the example of lower pair is turning pair, is screw pair, is spherical pair, is planar pair, is sliding pair. So all these comes under the category of lower pairs. And my dear, when we are talking about the higher pair, if contact is point or line, very good Ayush, very good Midun. So my dear, if we have point or line contact, like in rolling pair, we were having this body is connected with the surface at a point. So this is said to be the example of higher pair, my dear. Similarly, if you have cam and follower, so this is cam, my dear, and this is follower. This is follower. So if you see this cam and follower are connected with a point or line contact. So my dear, this example comes under the higher pair category. So my dear, this comes under the higher pair category. I feel everybody understood that. And my dear, whenever one body is completely wrapped over another, then it is said to be the wrapping pair. When belt is wrapped over the pulley, when rope is wrapped over the pulley, then my dear, like let us suppose this is the rope and let us say this is the pulley. So when this is wrapped over it, we will call it as a wrapping pair. But my dear examiners in engineering services exam, not in GATE, I will say, in engineering services exam, sometimes they are playing with your hearts. They are playing with your minds. In the question they will ask belt drive is an example of. When you see belt drive in your mind, it would be coming to answer as wrapping pair. But my dear, by chance wrapping pair would not be in your option. In your option you would be having higher pair, lower pair, both of them, cannot say. So my dear, in such situation what you are going to do? So my dear, I would like to tell you that if you want to understand that wrapping pair if not present in the option, then what should we tick on that? So my dear, then there are some possibilities I would like to say. If you see this as pulley and if you see this as rope, just by looking at this seems to be a kind of lower pair, because we can feel that rope is completely on the surface of pulley. So just by looking at this, you would be having in mind that wrapping pair should be close to lower pair. It seems to be like that. And whatever you are thinking is fine, guys, with the normal eyes. But there are something we cannot see from our normal eyes. For those things we need to use some special eyes, the inside story, the inner eyes. So my dear, when we are talking about that, if you would be using a microscope to see this, you will be able to see that this rope, whatever you have made, is not having that plain surface what I am showing you right now. Actually, this surface is not going to be that plain. There would be some surface roughnesses present like this. And actually when you touch the rope, you can feel it. In belt, you may not be able to feel. But in the rope, you can feel this roughness also, because roughness is very high. So my dear, similarly, when you will try to see the pulley, this pulley will also be having some surface roughness on its surface. So actually this surface of pulley would be like this. So my dear, when on this surface of pulley the belt would be coming, then my dear, the connection between belt and pulley would be something like that. The connection would be something like that. The connection between belt and pulley would be like this. It is not going to be on the surface because of roughness. So you can see the connection between belt and pulley is actually coming on some particular points. Here it is coming, okay, showing it with the light color. It is coming here. 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 So my dear, it shows they are near to multiple point contacts. They are near to multiple point contacts. So my dear, when we are talking about point contacts, we would be approximated it as higher pair. Now many students would be thinking that, sir, in that way we can also call sliding pair to be a higher pair. How? Because in that way also we would be having a cylinder like this. We would be having a piston like this, and those cylinder and piston would also be having some kind of surface roughnesses. But my dear, in case of cylinder and piston, my dear, we are generally going for micro finishing operation, because this application is very, very interesting and important. The operation going inside the cylinder, they are definitely affecting by surface roughness. So there we are going for micro finishing operation. But when we are talking about rope, belt, they are very cheap drives, cheap devices. So for such cheap drives and devices, we are not going for micro finishing operation. So when we are not going for the micro finishing operation for such cases, my dear, then my dear, when you are not going for the micro finishing operation, then there are chances of more roughnesses. Here surface roughness is not at that level. So here surfaces, if looks like plain, they are actually plain. So my dear, because of that, here you would be talking that it is a case of lower pair only, but not the higher pair. So in cylinder piston, it is always lower pair because we are going for micro finishing operations. So that is why it is always coming under the lower pair category. Yes or no, guys? Please tell me that. Very good, Manas. So just guys, like and share the session. I am saying again and again so that we can get more and more students in the class. So my dear, this is the third classification that we will see at the time of cam and follower. So it is not required because it is there in cam and follower. Now we are going for the types of joint. So my dear, when we are talking about the types of joint, whenever two links are connected together at one point, it is said to be a binary joint. Like in turning pair, we have link number 1, link number 2 connected together. It is an example of binary joint. Similarly, in case of cylinder piston, in cylinder and piston also we are having two links connected together. It is also considered to be a binary joint. So any place where two links are connected together, we will call it as binary joint. A slider and a connecting rod, also a binary joint. All these are examples of a binary joint. Now, my dear, we are moving to the next type of joint, that is ternary joint. When three links are connected together at a point, it is said to be ternary joint. You can see link number 1, 2 and 3. So here it is said to be ternary joint. Now, my dear, if you see, this is a cylinder, this is a piston. So my dear, cylinder, piston together, there are two links. If we also have a connecting rod, so my dear, they will become three links connected together, 1, 2 and 3. We will call it as ternary joint. Actually, my dear, when we are talking about three links connected together, ternary joint, the point is whenever we would be doing the calculation, whenever we would be deriving the formula for degree of freedom, in those formula we would be having the binary joints only. So as in those formula we would be having the term of binary joint, we must be knowing a conversion of ternary joint into binary joint. So my dear, if you are talking about one ternary joint, it seems like in this 1 to 2 is one binary joint, 2 to 3 is another binary joint, 1 to 3 another binary joint. It seems to be that there are three binary joint. But as I already told you, we need to check how much independents are there. Like in pure rolling, there are two motion, but independently only one motion is there. My dear, in case of ternary joint, it seems to be there are three binary joint, but independently you just make any two of them, third would be automatically coming. So independently there are two only. If you make the binary joint between 1 and 2, second binary joint between 2 and 3, between 1 and 3 is automatically coming. You need not to make it. So I will say one ternary joint is equivalent to two binary joints. Okay, one ternary joint is equivalent to two binary joint. Yes, guys. Let us move further. Now, my dear, we are talking about the quaternary joint. So when we are talking about the quaternary joint, my dear, so as the name suggests, if four links are connected together, if four links are connected together, such a joint is said to be quaternary joint. You can see 1, 2, 3 and 4. So this is a quaternary joint. And my dear, similar to the previous analysis, one quaternary joint is coming equivalent to three binary joints. These we are going to use in the calculation of degrees of freedom. Guys, please tell me till this point everybody understood or not, because after this I am going to start some other wonderful things. We have completed the types of joint. Now we are entering into kinematic chain, and just after the chain we are going to enter into degree of freedom, which is our heading for today. So my dear, I am not leaving anything. We are doing everything. The relation between higher pair and lower pair also we are going to see tomorrow. Sir, cylinder, piston and pin are not at the same point junction. Is it still? Yes, sonics mean. If you have any doubt into that, I can teach you in a different manner also. Okay, you just consider it that they are not connected together. So I just told you that this is cylinder, piston, a binary joint. A piston and connecting rod is a binary joint. So if you see this, these are two binary joint. One is cylinder piston, other is piston connecting rod. So that's what I said. Two binary joint is equivalent to one ternary joint. If you don't want to count ternary and directly count binary, that is also fine, because I need binary only for my calculations. Is it clear, sonics man? Please tell me that. Yes. So my dear, now we are going for the wonderful heading, that is kinematic chain. This is the heading in which we will continue with the degrees of freedom. So my dear, now just listen to me carefully. And today I would be telling you degree of freedom of a link, degree of freedom of a pair, degree of freedom for mechanism we will discuss tomorrow. So my dear, now kinematic chain, what it is? My dear, if I tell you what is a chain, that is very easy to understand. When a number of links are connected together, you have seen the chain of bike and chain of cycle. Some links are connected like this. You have also seen the gold chain which Bappida was wearing. Our mother, father, we are also wearing. Hai na? So we are having a number of things connected like this. It becomes a chain. In simple words, we can say if a number of links are connected, if a number of links are connected in such a way that first and last link is joined together, if a number of links are connected together in such a way that first and last link are connected together, then when first and last link would be connected together, it is said to be a chain. But my dear, okay, it is becoming a chain, it's fine. But what will make this chain to be kinematic? My dear, this chain is made up of various links which are joined with various types of pairs. So my dear, if relative motion between those number of links is a constrained motion, only then we would be calling it to be a kinematic chain. So my dear, now I am going to define this in the next slide. If all the links are connected in such a way that the first and last link connected together in order to get the closed chain, and if all relative motion in this closed chain are constrained, then such a closed chain is said to be the kinematic chain. Please tell me, everybody clear about the definition or not? Now my dear, this kinematic chain, we got it. Okay, if all the links are connected in such a way, first and last link connected together, it is going to be a chain. Relative motion constraint, it is a kinematic chain. And my dear, if one link is kept fixed, for this kinematic chain, this wonderful kinematic chain would become mechanism. So my dear, when you are going to fix one link of a mechanism, it becomes a kinematic chain. And my dear, when this mechanism is going to be utilized to get the work output, it becomes a machine. So my dear, here we are going to get the definitions of mechanism and machine. Now there is a very, very important point. It's fine when we are going to keep one link as fixed for a kinematic chain, it is becoming mechanism. It's fine, everybody got it, how it would be becoming mechanism. But what is the need of fixing the link? So my dear, input and output. Input is given with respect to the fixed link. Output is obtained with respect to the fixed link. So keeping a link fixed is a necessity. So always we need to fix a link. I would be giving you an example. This is not very appropriate example, but it would give you a feel of that. Whenever you were in first year, you were going to ED lab, engineering drawing lab. You were having drafter on one hand, one arm. On the other hand, you were having the folder of the sheets. So when you were entering into the ED lab, the first thing you were doing, what was it? You were taking the drafter out and fixing it with the table. Why? Because without fixing, you cannot give input, you cannot get output. Okay, so that's why always the first thing we are going to do is to fix a link. So my dear, this is how we are talking about machines. So for any machine, it should be a mechanism. For any mechanism, it should be a kinematic chain. So my dear, now you understood what is the need of kinematic chain. So my dear, if you want to make a mechanism or machine, it should be a kinematic chain. Then after fixing any link of this, you can get a mechanism. Yes. So my dear, when we have discussed this kinematic chain and we have discussed that what is the need of this kinematic chain to make mechanism or machine. So my dear, now it comes that what are the conditions? What are the conditions which should be satisfied for a given kinematic chain that we can say it is going to be a mechanism? So there are some condition. If any chain satisfies those conditions, then my dear, we call those chains as kinematic chains. So my dear, first condition I am going to write is L is equals to 2p minus 4. Here L is the number of links, P is the number of kinematic pair, and similarly there is another relation, that is J is equals to 3 by 2L minus 2. Here J is the number of binary joint, L is the number of link. So if any of these two conditions is satisfied by any of the given chain, it is called as kinematic chain. Now the point is from where these conditions are coming. So my dear, these conditions are being derived from the concept of degrees of freedom. So my dear, because of this, now we are going to discuss about the degrees of freedom. So first of all, I told you the need of degrees of freedom, because my dear, without getting the need, why we shall start something, why we are studying that thing, we must know the reason behind that. Because degree of freedom concept is very important to identify whether the given chain is a kinematic chain or not. Everybody understood or not? Please tell me that. Yes, please tell me that. We are starting the session now with the degree of freedom. Everybody understood? Shall we enter into the new field? Yes or no? Degrees of freedom? Yes, my dear, degrees of freedom? Fine. So guys, example of quaternary joint. Dear, don't worry. If you are talking about examples of quaternary joint, actually I have some questions there. I have. So I would be showing you in the question. Don't worry. Okay. In the question, I have the example of quaternary joint. Don't worry about that. So my dear, first of all, let us discuss the degree of freedom, which is the heading of today. Because the numericals of degree of freedom, there only I would be showing you all the types of joints. Okay. So don't worry about that. So my dear, we are talking about degree of freedom, what it is. My dear, this is not a thing you are looking for the first time. This is a thing you have studied many times. In physics, you have studied at the time of heat and thermodynamics in 11th class, when you were talking about the degrees of freedom of gases. And my dear, there you have discussed that in the kinetic theory of gases. So we are not going to discuss that here because this subject is not heat and thermodynamics. At the second time, when you were going for chemistry in first year, there you have studied a chapter named as phase diagram, and in that phase diagram you studied degree of freedom, and in that phase diagram degree of freedom was taught like that. It was defined as the number of independent. You also studied it in the thermodynamics Gibbs phase rule. It is the number of independent variables. Which variables? Intensive variable. Volume would not be counting. It is defined as the number of independent variables required to define state of motion. Sorry, state of system. In thermodynamics, state was important because state was telling you the usefulness of the system. If a system was at a high temperature, you were knowing that we can extract heat from it. If a system is at lower temperature, you were knowing we can give heat to it. If a temperature at higher pressure, we could say we can take work output from it. If a system is at lower pressure, you know we can give work output to it. If something is at lower temperature, you can use it as a sink. If something is at higher temperature, you can use it at thermodynamic source, heat source. So my dear, that's why their state of system was important. But now you are into a subject where we are discussing the motion. So in this subject, if something is important, that is motion. So my dear, that's why I would be defining degrees of freedom as the number of independent motions. Number of independent motions. So degree of freedom is number of independent motions, or you can also define as number of variables. Number of variables required to define. Number of variables required to define motion of the system. So my dear, the number of variables which are required to define the motion of a system is given the name of degrees of freedom. So my dear, if you are talking about independent motions or independent variable, you very well know one thing, that in kinematic chain, you want the relative motion between the links should be a constrained motion. You know, constrained motion means a unique motion. Unique motion means degree of freedom should be 1, because they are saying the number of independent motions. Number of independent motions means what? Degree of freedom should be 1. So my dear, if you are going for a kinematic chain, if you are going for a mechanism, what we are looking for is nothing but degree of freedom 1. But this is just I am giving you based on the normal concept. Now we would be deriving these things in a great detail. Let us start the discussion on the degree of freedom. First tell me whether you got this definition or not. That number of independent motion or number of variables required to define some motion. This is the definition of degree of freedom in theory of machines. Degree of freedom is a physics which can be used anywhere. So based on the applications, we have different definitions. Yes, very good, Sonics man. Sonics mean. Okay. So is it clear, guys? Shall we start now the discussion? I have just defined degrees of freedom in front of you. Yes. Are bolo bhai? Yes or no? And guys, just join my Telegram channel, Mechanical by Dheeraj Sardana. You will get this PDF along with handwritten notes. And from tomorrow onwards, tomorrow morning, you will be getting an assignment also on degrees of freedom questions. Okay. Yes, Malia, very good. Sonics, very good. Abhimanyu, okay. Great. So we are starting, guys, now. So my dear, first of all, we would be talking about an independent body. If we have an independent body in 3 dimensions, we need to see how many motion it can have. So we want to find out degree of freedom for an independent link in 3 dimensions. So my dear, if we have this independent body in 3 dimensions, it can translate in x direction. First of all, when I am going to make this coordinate system, always remember you cannot write anything x, y, z. Whenever you write coordinate system, it must follow the right hand thumb rule. It means if I am going to make a coordinate system like this, if I am writing this as x and this as y, so you would be putting your fingers in the x direction, rotate them towards y, and your thumb would be giving you the z direction. So this is going to be z. But my dear, let us say if we are going to make somehow in a different manner. If I am saying this as x, this as y. So my dear, this is x outside, this is y, z would be coming upward. Is it fine? No doubt about that. So my dear, if you are going to put this as x and this as y, then x is outside, y is like this, z would be coming in this direction. So in that case, z would be coming in this direction. So it must always follow the right hand thumb rule. Always remember that whenever you give any name x, y, and z. So if you see any independent link in this 3 dimension, so my dear, this link can have what type of motion? My dear, you can give it translation in x direction like this. You can give it translation in y direction like this. You can give it translation in z direction like this. Or if this link is there, we can translate it like this, we can translate it like this, we can translate it like this. 3 translation motions. You can rotate it about the x-axis like this. I am rotating this body about x-axis like this. You can rotate it about y. You can rotate it about z. So my dear, I would like to say for an independent body, there are 3 translation in x, y, and z plus 3 rotations in x, y, and z. So these 6 motions are the maximum possible motion for an independent link. Independent means, let us say guys, you are living alone. You are going for your BTech in some city, your parents are far away from you, and there you are not living at any PG or hostel, but you have taken an independent room where even those home owners, they are also, landlord are also not there. So you are living alone. You are free to come at any time. You are free to go at any time. You can come with anyone. You can come alone. Whatever you want to eat, drink, whatever you want to do, you can do. This is the condition of maximum degrees of freedom, when nobody is going to stop you from anything. So the maximum degrees of freedom for a kinematic link is 6. So my dear, we would be writing degree of freedom maximum for a link can be 6. Some people are saying this 6 to be 12. They would be saying, sir, not 6 but 12. How 12? My dear, they can say translation in positive x, translation in negative x. There are 2 translation in x. Positive y translation, negative y translation, 2y translation. Positive z, negative z, 2z translation. Rotation clockwise about x, anti-clockwise about x. There are 2 rotation in x. So likewise, we can go for 12 also. But my dear, in theory of machines, we are precisely and concisely discussing about the motion only. We are not interested in some of the machine where we are going for turning operation or some particular operation. Why I am saying this? Because my dear, we will be considering plus x motion and minus x motion to be same, plus y motion minus y motion to be same, clockwise rotation anti-clockwise rotation to be same. Why? Because our task is just to produce relative motion. But when this motion would be used in the machines, then my dear, if you are going for a turning operation, then definitely the motion of cutting tool in this negative x direction will give the operation to be processed, but in this direction there would be no turning operation happen. So when we are talking about production, degree of freedom would be 12, because their positive x translation and negative x translation would be having different meanings. So my dear, but right now the subject is theory of machines, so we would be taking the maximum degrees of freedom to be 6 only. Some of you may be thinking, sir, how you would be knowing that the question is from production or theory of machines? My dear, if it would be from production, there is the topic jigs and fixture, from where this question can come in degrees of freedom. So there you will find the options are more than 6 for such cases. Then you need to consider it 12 and assume it is from the topic only. Otherwise, you need to consider it to be 6 only. Is it clear, guys? Please tell me. We are just about to complete the session, guys. So this is about degree of freedom of a link. So my dear, now let us talk about pair. I always say pairing imposes restrictions. Pairing imposes restrictions. Till now you were living alone. You were free to do anything. You were free to come at any time. You were free to go at any time. You were free to eat anything, drink anything. Everything was okay for you. But suddenly you are having some pairing. Pairing means any kind of relative or relation. It may be with a girlfriend, maybe with a boyfriend, maybe with your parents are coming for some days, maybe your brother or sister who are elder to you are coming for some days to you. So in all those conditions, some of the motions are going to be cut off. They are going to be restricted this time. Like if you would be having girlfriend, you would be having different types of restriction. If you are getting married, different kind of restrictions. Parents would be coming, you would not be able to go outside in the odd times. You cannot be having a drink or eating anything in the home. So all those kind of restrictions would be coming. I'm just taking examples, guys. Don't take it in other sense. So the point is, pairing imposes restriction. Whenever some relation is made, whenever some pairing is there, then my dear, some of the motions are going to be restricted. So in that case, degree of freedom of the link will become 6 minus r. Here r is the number of restrictions. Number of restrictions. Or they are number of restricted motions. They are number of restricted motions. So my dear, you can find out the degree of freedom when we are knowing about the number of restrictions. So 6 minus r, r is the number of restrictions. Is it clear for everyone or not? Please tell me, guys. So please tell me, are you enjoying the topic or not? Yes. So we are coming to the last part for today. Degree of freedom is not completed today. We would also be taking first 20-25 minutes of tomorrow's class to go for degrees of freedom, okay, because we are going to practice a number of questions on that. So today we have just started degrees of freedom. So major numerical part would be coming from tomorrow onward, okay. So tomorrow onward you would be having a number of numericals, okay, because degree of freedom is the first topic from which numericals are coming in the examination. So degree of freedom's question we are going to do tomorrow. And tomorrow onwards you would be getting assignment for these classes, and those assignment would not be having very normal questions. They would be having some dangerous question, okay, because I want to prepare you for at any level. And at the end of this series I would be asking you for the feedback, and if you would be saying, sir, we enjoyed that series, we would be coming for such a series for other topics of this subject and other subjects also, because their target is to prepare you for the marks. Okay, so my dear, now we have seen the number of restrictions. Let us say we are taking an example of turning pair. I am just showing you. If we are talking about a turning pair is there between these two links. I am connecting these two with a pin. Okay, let us say this is the case. So you know the maximum degree of freedom it can have, we need to find out. So you know the formula for degree of freedom is F is equals to 6 minus R. So if we know about the number of restrictions, we can find out the degrees of freedom. So my dear, restriction is that motion which is not possible. And if you will try to do that motion, the pairing would be not there. Like if you are in relationship with someone, there are some conditions of that relationship. If you would not be following that, relationship is going to be break up. Is that or not? Yes, it is. So my dear, the same thing I would like to say, that is said to be restriction. So my dear, if you have these two links and they are connected with the pin like this, if this link want to translate in this direction, it cannot, because if it would be translating, it has to do breakup with the other link. So translation in X is not possible. Translation in Y is not possible because connection would be broken. Translation in Z direction would also be not possible. So all the three translation are restricted here. If you will try to rotate this link about X-axis, you cannot rotate it. The connection would be broken. If you will try to rotate this link about Z-axis, once again it is not possible. Connection would be broken. But my dear, if you will try to rotate this link about Y-axis like this, you can very easily rotate without any problem to this link. Why? Because in this condition, both link can rotate together. So they can remain together with that motion. So that motion is not restricted. You will say 3 translation and 2 rotations are restricted. So degree of freedom would be coming out to be 6 minus 5. 1 is the answer. So now you come to know for turning pair, degree of freedom for any link is going to be 1, because any link can have only one type of motion. So my dear, like this, tomorrow I would be going for a wonderful table, and then we will be deriving the expression for degree of freedom for various cases. For a mechanism, we entered into Kurzbach equation, then modified Kurzbach, and then Grubler's criteria, and then we would be entering into Grashof flow and all. So guys, I would be teaching you each and everything in a great detail. Don't worry about that. So shall we close the session today? Because I feel I explained you what is degree of freedom. Tomorrow we will see and derive the expression for mechanism, and we will see a number of questions. So guys, goodbye for this session. Thanks for joining. Thanks for your wonderful response. Just like the session before leaving. Join my Telegram channel to get the PDF and handwritten notes and assignment of this chapter. So goodbye for the session. Thanks for joining again. Goodbye.